The Daily Grind operates a chain of 4 cafes in Singapore. This month, the owner must make a difficult decision: renew the Marina Bay lease at $9,600 a month or walk away. This chart shows the total monthly revenue for the entire chain over that 18-month period. Looking at the top-line number, the business appears perfectly flat. But clean rows of data tell us nothing on their own. To evaluate the business, we must group the data using 4 specific beats: identify the business question, define the grain of the data, pick an aggregation method, and run a final check. At this grain, the data provides a false signal. That flat line masks a critical threat to the business. This diagram shows how a computer reads dates when they are imported as raw text. Text sorts alphabetically. Because the character 1 comes before 9, the computer places October ahead of September. We have to convert those strings into chronological objects. But there is a silent trap. If the data says 03/6, Pandas will guess the format. It might parse June 3rd as March 6th. Because both are valid calendar days, no error is raised. Your timeline simply corrupts in silence. Once the timeline is formatted, we can change the grain of the data. We use a function called resample to gather hundreds of daily till receipts and bucket them into larger monthly groups. How we aggregate those buckets changes the results. If we sum the daily revenue, February always looks like a crisis. But February just has fewer calendar days. If we average the daily revenue instead, we see the true daily performance of the cafes. A simple daily average still leaves us with wild swings between busy weekends and quiet weekdays. To fix this, we use a rolling average, calculating the mean over a moving 7-day window to strip out the weekly rhythm. This chart shows the rolling average for the Marina Bay location. With the noise smoothed out, we can distinguish a slow slope from a sudden step. In the first week of November, revenue took a sharp step drop and stayed down. A competitor opened next door. Until we handle time mathematically, sudden real-world events stay buried inside statistical noise. Knowing revenue dropped isn't enough to evaluate the lease. We need to merge our sales data with separate spreadsheets containing rent costs and business targets. This spreadsheet shows our business targets in wide format. It is built for humans, spreading the months across the top. But a computer cannot group or filter by a column header. We use a function called melt to fold those headers down into rows. It creates a vertical format where the month is finally an actual data point. With both our sales and targets in long format, we combine them using a datapiece join, aligning the numbers by the specific cafe location. An inner join carries a specific danger. It only keeps records that exist on both lists. Our sales data includes $61,000 from a temporary pop-up kiosk. Because the kiosk isn't on the target list, an inner join silently deletes that entire $61,000. To prevent this, we use a left join. It preserves every row from our primary sales list, leaving blanks for missing targets rather than deleting the revenue. Without strictly controlling the shape and join logic of the data, an analyst will silently erase financial realities. With our data merged, we run a split, apply, combine operation. We split the sales records by location, apply our math to each group, and combine the answers into one table. Splitting the chain total by outlet shows what that top-line number was hiding. Marina Bay's revenue is plunging, while the Holland Village location is climbing by the exact same dollar amount. Because they move in opposite directions, a check shows a strong negative correlation. But these are independent cafes miles apart. One didn't cause the other to grow. The chain's flat revenue total was simply the result of these two opposing business trajectories canceling each other out. To deliver this insight to the owner, we use the pivot function. This snaps the machine-readable data back into a wide spreadsheet format for human presentation. Before making any recommendation, we run a final check. We verify that the total of our new table perfectly matches the raw sales total we started with. We can now see exactly why Marina Bay is struggling. By running a crosstab analysis against the staff roster, we find that when revenue dropped in November, management never reduced their staffing hours to match. This table shows the final reality. Between the revenue drop, the fixed $9,600 lease, and the oversized staff roster, the cafe is burning cash. It is earning a dismal $19.92 per staff hour. Data analysis is the structural extraction of reality. By managing time, reshaping the tables, and grouping the data, we replaced a deceptive flatline with an undeniable mandate for business action.